Which planet has 14 moons named after sea nymphs, a 165-year orbit around the Sun, ravaging supersonic winds, and just one close-up image taken by a spacecraft? If you guessed Neptune, you are absolutely right. Neptune is the 8th planet from the Sun and the planet with the greatest known distance from the Sun. Astonishing and unexpected discoveries about this planet have lately been made by NASA, the leading space agency of the United States, which may alter how we view it. What on Neptune has NASA discovered? Exactly why does NASA wish to travel to Neptune in the future? Without further ado, let's delve into why NASA has just revealed Neptune is not what we're being told. Neptune has a diameter of about 50,000 kilometers, making it the 4th largest planet in our solar system. It is roughly 4.5 billion kilometers away from the Sun and completes one orbit of the Sun every 165 Earth years. The presence of methane in Neptune's atmosphere gives the planet its magnificent blue color, which is well known. Similar to Saturn, Neptune features a sophisticated ring system. However, it is considerably fainter and less obvious. Moreover, it is known to have 14 moons, the largest of which is Triton, which is comparable in size to the moon of Earth. As it orbits Neptune in the opposite direction from the planet's rotation, Triton is one of our solar system's most peculiar moons. The penultimate planetary target for NASA's Voyager 2 spacecraft, Neptune, was first observed by the probe in the summer of 1989. 12 years after departing from Earth in 1977, Voyager 2 made its closest approach to any planet, passing 4,950 kilometers or 3,000 miles above Neptune's North Pole. 5 hours later, Voyager 2 flew by Triton, the biggest moon of Neptune, at a distance of around 40,000 kilometers or 25,000 miles. The Big Dark Spot, a gigantic storm visible in Voyager 2 images, was also very large. But whereas Jupiter, Saturn and Pluto were photographed by the Galileo, Cassini and New Horizons missions in highly precise detail, Neptune and Uranus were captured by Voyager 2 in rather simplistic photographs. Let's examine the most recent NASA discoveries in more detail. Neptune appears to be a simple, unremarkable ball of molecules at first view, but there might be something extraordinary hidden beneath the surface of this world, a steady downpour of diamonds. The term ice giants, which may evoke a Tolkien-esque creature, is actually used by astronomers to describe Uranus and Neptune, the 2 farthest planets of the solar system. The term, however, is confusing because it has nothing to do with ice in the way that you would often understand it, such as ice cubes in your drink. These planets' differences can be attributed to their composition. Jupiter and Saturn, the 2 gas giants in the solar system, are almost entirely composed of the gases hydrogen and helium. These enormous planets were able to grow to their present sizes due to the rapid accretion of those components. Uranus and Neptune, on the other hand, are primarily composed of water, ammonia and methane. There really isn't a clear reason why astronomers refer to these molecules as ices, other than the possibility that those elements were solid when the planets originally formed. Therefore, let's dive into the not-so-icy depths. There is a significant amount of water, ammonia and methane deep beneath the green or blue cloud tops of Uranus and Neptune. Yet the stony cores of these ice giants are undoubtedly surrounded by elements that are squeezed into unusual quantum states. The quantum oddity eventually transforms into a highly pressurized soup, which typically becomes thinner as you go closer to the surface. But the truth is that we know very little about the innards of the ice giants. As Voyager 2 flew by on its historic voyage, it was almost 30 years ago that we last received close-up data of the 2 worlds. Since then, other orbiting missions have visited Jupiter and Saturn, but our observations of Uranus and Neptune have only been possible through telescopes. Astronomers and planetary scientists must use this scant information in conjunction with laboratory studies that attempt to mimic the circumstances of the innards of those planets in order to comprehend what is within those worlds. Also, they employ a lot of traditional math. Astronomers can better grasp a problem based on limited data by using mathematical modeling. They came to the conclusion that Neptune might have so-called diamond rain through a mix of mathematical modeling and laboratory tests. So, is it raining diamonds? Diamond rain was initially mentioned prior to the 1977 launch of the Voyager 2 mission. The justification was rather straightforward. We know what Uranus and Neptune are comprised of, and we are aware that material becomes hotter and denser as it travels deeper within a planet. The mathematical modeling fills in the details, including the likelihood that the innermost portions of the mantles of these planets have temperatures around 7,000 kelvins, that's 12,140 degrees Fahrenheit or 6,727 degrees Celsius, as well as pressure 6 million times greater than those of Earth's atmosphere. The same models inform us that the uppermost mantle layers are slightly less pressurized, 200,000 times Earth's atmospheric pressure, and cooler, 2,000 Kelvin or 3,140 Fahrenheit or 1,727 Celsius. So it's only logical to wonder what happens to water, ammonia and methane under conditions of that kind of heat and pressure. Particularly with methane, high pressures can split the molecule, releasing the carbon. The carbon then connects with its siblings to form lengthy chains. The lengthy strands are then compressed together to create diamond-like crystalline patterns. As it becomes too hot, the thick diamond formations fall down the mantle layers until they evaporate, float back up and resume the cycle, hence the name diamond rain. Sending a spacecraft to Uranus or Neptune would be the best method to verify this theory. It won't be an option for a while, so we'll have to settle for the less ideal approach: lab tests. Powerful lasers can be used on Earth to briefly mimic the pressures and temperatures seen inside ice giants. A polystyrene experiment, sometimes known as styrofoam, produced diamonds that were nanometers in size. Polystyrene isn't found in large numbers on Uranus or Neptune, but it was far easier to work with in the lab than methane, and it probably behaves very similarly. The diamonds might also be able to grow much larger than nanoscale, since Uranus and Neptune can sustain those pressures for a lot longer than a lab laser. The final outcome? Diamond rain is a highly real phenomenon based on our current understanding of the ice giant's interior structures, chemical makeup, laboratory experiment findings, and mathematical modeling. The dark storm mentioned earlier was among the amazing photographs of Neptune's atmosphere that NASA's James Webb Space Telescope recently snapped. The pictures display the rings, moons, intricate patterns, and hues of Neptune's atmosphere. Large ground-based observatories like the Keck Observatory in Hawaii have allowed for limited studies of Neptune's weather, but practically all of what is known about atmospheric characteristics comes from Voyager 2. Why Voyager 2 had issues at Neptune? Only 0.001 times as much sunshine hits Neptune as the Earth. Voyager 2's camera had to take long exposure pictures in such a dim environment. Unfortunately, it was moving too quickly for such to be possible without seriously causing image blur. At its closest approach, Voyager 2's thrusters fired slightly, turning the spacecraft to aid in maintaining the camera focus on Neptune. NASA's Deep Space Network antennas in Spain, Australia, Mexico and California had to be stretched to 230 feet or 70 meters due to the distance from Earth. Voyager 2's images of Neptune took 4 hours to arrive on Earth. As it quickly approaches its rendezvous with the massive planet, the Voyager 2 spacecraft displays more detail than ever before of Neptune's blue-green atmosphere. This image in color was captured at a distance of around 16 million kilometers and reveals a number of intricate and perplexing atmospheric phenomena. Around 13,000 kilometers by 6,600 kilometers in size, the Great Dark Spot GDS at the center is as big along its longer axis as the Earth. Let's instead talk about the reasons NASA hopes to travel to Neptune in the future. We all know that our beloved Neptune isn't often depicted in family photo albums of the solar system. And that's because despite Voyager 2's trip to Neptune, there is still a lot we don't know about the planet. For instance, we still don't understand why the planet's magnetic field is uneven or why its winds are so powerful. Triton, a moon of Neptune, is another fascinating body in our solar system. It is assumed to be a captured Kuiper Belt object, and due to its peculiar orbit and makeup, it may have formerly been a dwarf planet. The fact that Triton is the only major moon in our solar system to orbit its parent planet in the opposite direction from the direction the planet rotates raises issues about how it was captured and how it has changed over time. Also, it is believed that Triton very definitely has an ocean of liquid water beneath its surface. Isn't it about time we returned? More than 3 decades have passed in complete darkness. Why has Neptune gone unnoticed for so long? There are several rational explanations for why Neptune has been disregarded for so long. Constraints on trajectory came first. Only once every 12 years is there a chance to travel to Neptune for a reasonable price. Basically, it depends on where Jupiter is in relation to Neptune. Also, there is a constrained budget for robotic exploration, and traveling to Neptune is expensive. The success of New Horizons at Pluto, where it found the largest known glacier in the solar system, a blue atmosphere, and proof of an interior ocean of water ice, however, demonstrates the value of a quick flyby mission. That is exactly what's being planned for the Trident mission, but it won't be heading to Neptune exclusively or even primarily Triton, which is thought to be geologically active and very definitely has an ocean beneath its surface, will really be its intended target. Insights into the Kuiper Belt, the region of the solar system beyond Neptune where millions of frozen objects are found, would also be gained via a mission to Triton. After a 2026 launch, the Trident flyby, which is roughly modelled after New Horizons flyby of Pluto in 2015, would take place in 2038. Make your mind up time is about to arrive, because the curves will line up once more in 2026. In 2026, Jupiter offers a good chance to help with gravity, enabling a rather straightforward ballistic trajectory. This allows us to deploy smaller launch vehicles and smaller spacecraft because we don't need to carry as much propellant. That is what makes the mission reasonably affordable. We would likely need to deploy a much bigger and more expensive launch vehicle without gravity aids. If we don't launch by 2026, we'll either have to wait an additional 12 years for a good launch window or use a bigger, maybe more expensive launch vehicle. The following opportunity would be a launch in 2038 for a flyby in 2050, since Jupiter orbits the Sun every 12 years. New discoveries and unforeseen surprises are always a possibility with space research, just like any other endeavor. We can learn more about the solar system and the universe as a whole by sending a spacecraft to Neptune, according to scientists. Although it would be difficult and expensive to launch a spacecraft to Neptune, there could be huge advantages to doing so. We may have the chance to see this enigmatic planet up close in the future as technology develops and our understanding of the universe expands. Thanks for watching another episode of Voyager. While you're still here, make sure to click the video on your screen for more mind-blowing videos about space.